So this is the new series where we solve one physics problem every day. So today problem is electromagnetism. So you have a static charge. You have a static charge distribution which provide a radical electric field, because this is e to er, which is along the radical direction. This is spherical coordinate. And you have this electric field given this by expression a, b are constant, and you need to find the charge density. So whenever you have electromagnetism problem, where you go is look for Maxwell equation. And we know Maxwell equation. From Maxwell equation, we know this is one of the Maxwell equation. So now the answer, you know what to do. There's nothing tricky here. Basically, you need to find the you need to take the divergence with the electric field, and we know the divergence in spherical coordinate. You can look it up somewhere online. Nobody remember divergence in spherical coordinate, but we know this is only dependent on r, so the r factor come out to be r divided er. So we're not gonna care about like theta or like our azimuthal angle. We're not gonna care about other angles. So now the answer, this is pretty much very straightforward. This is 1, so you have 1 by a b r divided, this is r square actually, and yeah, so this is basically cancelled out, so you have ar e to the power minus br. Now we can plug this here and get the answer. So once we have that, we can plug that here. Okay, a comes out a square. Now take the derivative of the first, multiply with the second, take the derivative of the second, and multiply with the first. So if I try to simplify this come out to be e to the minus br 1 minus br. So this is basically, so now the electron density is E times E divided by R square minus E br 1 minus br. Okay, so this is our answer. And you can see this electron density can become negative, can become positive, depending on our if br is less than 1, greater than 1. So I hope you like this video. If you do, give the thumbs up, and I will see you next time.